Hurricanes, vast swirling storms that can span hundreds of miles. They are capable of unimaginable destruction, leaving behind a trail of devastation that can take years to recover from. These powerful forces of nature remind us of the awesome power of our planet, a power that can reshape landscapes and alter lives in an instant. Hurricanes form over warm ocean waters, typically in tropical regions where the sea surface temperature is at least 80 degrees Fahrenheit. They draw energy from the heat and evaporation of the ocean, a process that fuels their growth and intensity. As warm, moist air rises and cools, it condenses into clouds. This process releases latent heat, which further powers the storm. This condensation forms clouds and releases even more heat, fueling the storm in a self-sustaining cycle that can last for days. Hurricanes are classified by their wind speed, a critical factor in determining their potential for damage. The Saffir-Simpson hurricane wind scale ranges from Category 1 to Category 5, with each category representing increasing wind speeds and potential for destruction. Category 5 hurricanes are the most intense, with wind speeds exceeding 157 miles per hour. They have sustained wind speeds of 157 miles per hour or higher, capable of causing catastrophic damage to buildings, infrastructure, and natural landscapes. These storms bring torrential rainfall, high waves, and storm surges that can inundate coastal areas. Coastal areas face the brunt of a hurricane's fury, often experiencing severe flooding and erosion. The power of a hurricane is awe-inspiring yet terrifying, a reminder of nature's ability to both create and destroy. We must understand these storms to prepare for their impact, taking measures to protect lives and property. By learning about hurricanes, we can mitigate their devastating effects on human lives and property, ensuring a more resilient future for communities in their path. Hurricanes leave behind a trail of destruction. One of the most visible impacts is erosion. Powerful waves and storm surges batter coastlines. Beaches erode, cliffs crumble, and landscapes are reshaped. Erosion can change the physical geography of an area. It can also damage or destroy infrastructure and homes. Property damage is another significant consequence. High winds tear off roofs, shatter windows, and topple trees. Heavy rainfall causes widespread flooding. Homes and businesses are inundated with water. The cost of repairing and rebuilding after a hurricane can be staggering. Communities are left picking up the pieces. The financial toll of hurricanes is immense. The damage to property, infrastructure, and businesses can amount to billions, even trillions of dollars. Insurance companies face massive payouts. Governments allocate significant funds for disaster relief and recovery efforts. The economic impact extends beyond immediate damage. Businesses may be forced to close temporarily or permanently. Tourism and other industries suffer losses. Disrupted supply chains lead to shortages and price increases. Rebuilding and recovering from a hurricane is a long and costly process. Scientists are studying the link between climate change and hurricane intensity. Warmer ocean temperatures provide more energy for hurricanes to form and intensify. Rising sea levels exacerbate storm surges, leading to more coastal flooding. Changes in atmospheric circulation patterns may also influence hurricane tracks and intensity. While more research is needed to fully understand the complex relationship between climate change and hurricanes, the potential for more intense and destructive storms is a growing concern. It underscores the urgent need to address climate change and mitigate its potential impacts. Section 5. The hurricane life cycle, from birth to dissipation. In this section, we will explore the fascinating journey of a hurricane from its inception to its eventual dissipation. Hurricanes follow a distinct life cycle, marked by several stages of development and transformation. They begin as tropical disturbances, which are essentially clusters of thunderstorms. These thunderstorms form over warm ocean waters, where the sea surface temperature is at least 26.5 degrees Celsius. If conditions are favorable, such as low wind shear and high humidity, the disturbance can develop into a tropical depression. A tropical depression is characterized by a closed circulation of winds with wind speeds of less than 39 miles per hour. This stage is crucial as it sets the foundation for further intensification. As the system strengthens and wind speeds increase, it becomes a tropical storm. At this point, the storm is given a name and starts to exhibit more organized patterns. Once wind speeds reach 74 miles per hour or higher, it is classified as a hurricane. The hurricane structure becomes more defined, with a well-developed eye and eye wall. Hurricanes weaken as they move over cooler water or land. This is because they lose access to the warm ocean waters that provide the energy and moisture needed to sustain them. Without this source of energy, they lose their strength and begin to weaken. The wind speeds decrease and the storm structure starts to break down. Eventually they dissipate and their winds subside. The remnants of the hurricane can still bring heavy rainfall and cause flooding, but the intense winds and organized structure are gone. Section 6. Anatomy of a hurricane. Understanding the characteristics. In this section, we will delve into the various elements that make up these powerful storms. Hurricanes have several key characteristics that define their structure and behavior. At the center of a hurricane is the eye, a calm and clear area of low pressure. This region can be deceptively peaceful, often giving a false sense of security. Surrounding the eye is the eye wall, a ring of towering thunderstorms. This is where the most intense winds and rainfall occur, creating the most dangerous part of the hurricane. Extending outward from the eye wall are spiral rain bands, which also produce heavy rain and strong winds. These bands can stretch for hundreds of miles, affecting areas far from the storm's center. The size and intensity of a hurricane can vary greatly, depending on various factors such as sea surface temperatures and atmospheric conditions. Some hurricanes are relatively small but intense, packing powerful winds and heavy rains into a compact area, while others are large and sprawling, covering vast regions with their influence. Understanding the structure and characteristics of a hurricane is crucial for predicting its potential impact and developing effective preparedness strategies. Meteorologists use this knowledge to forecast the path and strength of hurricanes, helping communities to prepare and respond effectively. Section 7. The human cost: lives lost and communities shattered. The human cost of hurricanes is immeasurable. Lives are lost due to drowning, injuries from flying debris, and the collapse of buildings. The trauma of experiencing a hurricane can have long-lasting psychological effects. Communities are torn apart, with homes and livelihoods destroyed. The aftermath of a hurricane presents numerous challenges. Access to clean water, food, and medical care becomes limited. Displacement and homelessness are common. Rebuilding communities and restoring a sense of normalcy takes time, resources, and resilience. Section 8. Preparation and mitigation: lessons learned and future strategies. Hurricanes are a recurring threat in many parts of the world. We must learn from past experiences to improve our preparedness and mitigation strategies. Building codes and infrastructure must be designed to withstand hurricane-force winds and flooding. Early warning systems are crucial for providing timely evacuations. Public awareness campaigns can educate communities about hurricane risks and preparedness measures. Investing in research and technology can improve hurricane forecasting and tracking. By taking proactive steps, we can minimize the loss of life and property from these devastating storms. Section 9. The importance of forecasting and early warning systems. Accurate and timely forecasting is essential for reducing the impact of hurricanes. Meteorologists use sophisticated computer models and data from satellites, aircraft, and buoys to track hurricanes and predict their path and intensity. Early warning systems disseminate this information to the public through various channels, including television, radio, and mobile devices. These warnings provide crucial lead time for evacuations, securing property, and activating emergency response plans. Section 10. A call to action: global response to a global threat. Hurricanes are a global threat that requires a global response. International cooperation is essential for sharing data, coordinating relief efforts, and supporting vulnerable communities. Developed nations have a responsibility to assist developing countries in building resilience to hurricanes and other natural disasters. By working together, we can strengthen our collective capacity to prepare for, respond to, and recover from hurricanes. This includes investing in research, technology, and community-based initiatives that promote resilience and sustainability. Section 11. Hurricanes: a reminder of nature's power and our vulnerability. Hurricanes stand as a powerful reminder of nature's raw power and our own vulnerability. These awe-inspiring storms can reshape landscapes, devastate communities, and claim lives, yet they also inspire us to learn, adapt, and innovate. By understanding the science behind hurricanes, respecting their destructive potential, and working together to prepare for their impact, we can mitigate the risks and build more resilient communities. In the face of nature's fury, human ingenuity and compassion must prevail.